In this lesson, we're going to learn to take the derivatives of logarithmic functions. Just like e to the x is the simplest exponential function from the point of view of calculus, there is a simplest logarithmic function from the point of view of calculus. It is the natural logarithm, ln of x. It can also be written as log base e of x. This e here is the same e as is in e to the x. It's the simplest logarithmic function because it has the simplest derivative. The derivative ln x is just 1 over x. Now, ln x, even though it has a simple derivative, is still not quite the most natural logarithmic function to take. The reason it's unnatural in some sense is it's only defined for positive values of x. If you look at the graph of ln x, it looks like this. It's only defined for x values to the right of the y-axis. If we want to make another logarithmic function which is defined for all x values, we could take the mirror image of this one on the other side of the x-axis. If we take this mirror image, this function we get when we put those two things together is the natural logarithm of the absolute value of x. It turns out that this function, the natural logarithm of the absolute value of x, has the same derivative as ln x. Its derivative is also 1 over x. And the reason these two functions have the same derivative is because ln x is a part of ln of the absolute value of x. Its graph is a part of the graph of ln of the absolute value of x. They both have the same derivative. The first two examples are examples of functions whose derivatives we can find using the rules for ln x and ln of the absolute value of x. For the first function, we have f of x is 4 ln x minus e to the x plus x to the 5. The first step is to use the sum and difference rules to say that the derivative here is going to be the sum and difference of each of the derivatives taken separately. So we're going to have 4 ln x prime minus e to the x prime plus x to the 5 prime. Then we use the constant multiple rule to rewrite 4 ln x prime as 4 times the derivative of ln x. And then we're still going to have minus e to the x prime plus x to the 5 prime. Then we take the derivative in each case. The derivative of ln x is 1 over x. The derivative of e to the x is e to the x. The derivative of x to the 5 is 5x to the 4th. Then we simplify 4 times 1 over x. We can rewrite as 4 over x minus e to the x plus 5x to the 4th. For the next example, we have an ln of the absolute value of x, but otherwise the procedure is going to be exactly the same. First step is to use the difference rule. Y prime is the derivative of the first function, 6 ln of absolute value of x prime, minus the derivative of the second function, 7 to the x prime. Then we use the constant multiple rule. The derivative of the first function is going to be 6 times the derivative of ln of the absolute value of x minus, again, we're still going to have the derivative of 7 to the x. Then we take the derivatives. The derivative of ln of the absolute value of x is 1 over x. The derivative of 7 to the x is 7 to the x ln 7. And we just simplify this by rewriting it. This is 6 over x minus 7 to the x ln 7.